Welcome back. This is John Meter from Northern Stars Planetarium. We're going to do another Constellation Charades today. I've got a nice little constellation to share with you. I think you're going to like it. Hopefully you've done this before, and if you haven't, welcome, and I think you'll have fun even if it's for the first time. Alright, let's get started. I always like to start, as some of you know, with the brightest star in the field today. And the brightest star in our star field we're going to draw today is way down in the southwest, right over here in the corner. So right down here we're going to draw a really bright star. And we make them look bright when we draw them by making it a little bit bigger than the others. So make this a little bit larger than the other stars we're likely to draw today, so you know that it's one of the brighter stars in the sky. So we've got one right down in the southwest in the corner. From here, almost everything else is in the northern half of our picture today. So we're going to go way up to the top and go to the next brightest star, which will be this one right here. So this one's not as bright as the one down in the corner, but it's the second brightest, so make it a fairly bright star that stands out. You can give it points like I'm doing. If you like, and you want to be more realistic, just make dots. Big dots for the bright stars and fainter dots for the fainter stars, because after all, stars aren't really pointed, they're round. But we make them pointed, I think, because it's a tradition, and I think it's a way of making them look like they're twinkling. So now we have two stars in our field. The brightest one in the corner and another bright one up here a little in the north-northwest. From that bright star, the rest are going to be all about the same brightness, or at least most of them. We're going to go to the east and draw a little bit fainter star right there, like that. That was easy. Go about the same distance further east and put another one. Another set of 3 stars in a row, but they're not the same brightness. This one is far brighter than these two. Once you get that, we're going to start moving up on each side. So while we're here, let's go up and diagonal a little bit to the northeast and put another one about the same brightness there. And then we're going to curve into the north a little bit and put one right there too. So we have a nice little curve of stars in the sky. Come back to our bright star here, and we're going to go the other way now and curve up. So from here, rather than keep going straight, we're going to curve up to the northwest a little bit. Put one there, about the same brightness as these others. And then curve back in and put another one right there. So now we have a nice little half circle. Isn't that cool? A nice circle of stars in the sky. It really stands out when you go outdoors and look. And this is a group of stars you can see in the springtime and through a good part of the summer as well. So it's one that's going to be visible for a good part of the year. There is a star a little bit fainter inside the circle right about there. So make that a little faint one. It's not very bright, but it's an interesting star. We'll talk about that in a couple of minutes. Does anyone recognize our constellation yet? Well, let's draw some lines. If we start up at this end, what we're going to do is just connect our half circle like this. And like that. And then we're going to come up here, then up here, and we're going to ignore the one in the middle. That's the entire constellation. It's called Corona Borealis. Let's write that one in. We've got plenty of space here. We're going to do it at the top though. C-O-R-O-N-A, Borealis, B-O-R-E-A-L-I-S. Corona means crown. Borealis means north. So this is the northern crown. Now it's important to remember that it's the northern crown. Don't just go calling it the crown, because low in the southern sky in the summertime, there's another half circle called the southern crown. Got to keep your crown straight. And sometimes people refer to the famous constellation of Cassiopeia the Queen, which looks like a letter W, and the W's kind of look like crowns, so some people refer to that as the Queen's crown. 3 possible crowns. We're talking about the northern crown today. So here we have Corona Borealis. Now it's not always been known by that. It's been referred to by many different things. The Arabs, the oldest recognition of this group of stars, refer to it as the dish, the broken dish. And you can see it's kind of round like a plate, and it's broken. Part of it's missing, so it's the broken dish. The Greeks referred to it actually as a wreath, like you'd wear on your head perhaps, as opposed to a Christmas wreath. It is the Latins, the Romans, who referred to it as the northern crown. Now, along with that, the brightest star here has 2 names. It actually has many names, but we still call it by 2 names. The oldest one, Alphecca, and we spell that one A-L-P-H G-E-C-C-A. And Alphecca comes from the Arabs, and the Arabs referred to as the dish, and Alphecca was the brightest spot on the dish. Now the Latins, the Romans, referred to it as gemma, G-E-M-M-A. And since they referred to this as a crown, and crowns often are covered with diamonds and rubies and sapphires, gemma was the brightest gem in the crown. Sometimes it's referred to as the pearl of the crown. But I like that idea of having the bright gem on the crown, something that's very common. So we see a little bit of the lore behind this. Now, you might wonder, well, what does that bright star down the corner have to do with Corona Borealis? The answer is, it's not even part of Corona Borealis, but it's part of the lore of Corona Borealis. Around the world, people made up lots of stories about constellations. And the Shawnee natives referred to this not as a crown or as a wreath or even as a dish. They referred to it as the 7 heavenly sisters. Notice that there are 7 stars, 1, 2, 3, 4, 5, 6, 7, in a circle, like they were dancing. Well, there's a great hunter. He was called White Hawk, and White Hawk fell in love with the youngest of the sisters and the prettiest of the sisters, which of course was what we call Gemma or Alphecca. And he snuck up into the sky as a mouse so they wouldn't recognize him. And when he got close to her, he turned himself back into the great hunter he was, and the two of them fell in love, and they came down to earth and got married and all those wonderful things. But she missed her sisters, so she wanted to occasionally go back to the sky. And when she went to the sky, she became Gemma. He went to the sky too, but he became this star right here, which they called the White Hawk. We better know it today as Arcturus. Arcturus is about 20 degrees from the Northern Crown. It's actually in a totally different constellation, which we might talk about someday when we do another one of these. But it relates to the Northern Crown in that it is the hunter who married the star that we call Gemma. And I've never seen them call her by any specific name, just the youngest sister. So we see a relation to other stars in the sky to this as well. Now, Gemma itself is actually an eclipsing binary. That means it's a double star, which a lot of stars are double, and they go around each other, which most binary stars all do. But this one is going around so that every once in a while it kind of goes, one goes in front of the other. And that makes it very, very, very slightly in brightness. Not enough so you wouldn't notice it with your eyes, even if you watched it all the time. But astronomers who can measure the brightness very finitely and definitely, they can measure that drop in brightness as one goes in front of the other. So it's an eclipsing binary. There are 2 stars here, though, that I think are really fascinating. One you can't even see. I'm going to put a dot where it is so you know where it is. It's just outside the crown, right about here. So I'll put that little dot. But please remember, you can't see that with your eyes. You can't even see it with binoculars. That star is at 10th magnitude. Magnitude is a way of measuring the brightness of stars. So with magnitude, the higher the number, the dimmer it gets, because stars get a lot dimmer than they do get brighter. But if you're in a really dark spot in the countryside, you can see down to about 6 magnitude. This star has a magnitude of 10th magnitude, which means you won't see it with your eyes or with binoculars. You'll definitely need a telescope to see it. Well, there are a lot of stars like that. Nothing special about a 10th magnitude star. There are millions of them in the sky. But this one is special because back on May 12th, 1866, suddenly it became brighter than Fecca. Brighter than Alphecca. Alphecca is 2nd magnitude. It's a fairly bright star. And it became 2nd magnitude as well. It lasted 8 days, then it faded away and disappeared. They didn't know what that was happening back then, what was going on. Did the same thing on February 9th, 1946. It suddenly got brighter, up to just over 3rd magnitude. Still pretty bright. And after a week or so, it faded away and disappeared, and it hasn't done it again since. We do know what is happening with this star, and by the way, it's got a cool name. It's called the Blaze Star, because it blazes into brightness, and then it just disappears. So let's label it. And since it's an exciting star, we're going to label it in red, the Blaze Star. Right there. This is a binary star too, but the 2 stars aren't equal. One is a red giant, so let's draw it on here. We got plenty of space. It's a really big star like this, and it's red, and it's not very bright. when it's dim at 10th magnitude, the light you do see with a telescope is the light of this red giant right here. Red giant star. The star is way bigger than the sun. It's a huge star. We've talked about big stars earlier in some of the earlier videos. Now its companion, on the other hand, is not a bright star. It's a white dwarf, and comparatively, it would be about that big. It's really tiny. But it's denser and has a lot of gravity. And so what this little star is doing to its friend here, as they go around each other, is pulls material off. Stuff falls off the red star and gets pulled into the white dwarf. This one's a white dwarf. And it starts clouding around it and clouding around it and building up and building up and building up and building up, and then it ignites and flames into brightness. And within a week, it's burned up all that fuel and it goes back to 10th magnitude again. And it takes years for it to gather enough material off its old friend, stuff falling on, falling on, falling on, and periodically it flares up and becomes bright for a week or so, and then it fades back again. That's what's happening with the blaze star, right there. Well, that's called a nova, not a supernova. A supernova is a star that explodes when it dies. The star is not dying. A nova is when a little star, a white dwarf, pulls material off a companion and then occasionally flares up. So we have a nova, N-O-V-A, just like the TV show on PBS. Now, let's go to this star. We need to get rid of the red pen on this one. This star right here is an interesting star because you can see it with your eyes. It's at 6th magnitude, and remember that's about the limit of what we can normally see from a dark spot. This star's name is, well, where are we going to put it? Let's put it over here. R, Core, Bohr. Isn't that a weird name, R, Core, Bohr? Kind of fun to say, R, Core, Bohr. Well, I'm not sure where the R came from, but Core stands for corona and Bohr stands for borealis. So you'll often see it just labeled as R on the map. And this is sometimes referred to as a reverse nova. So most of the time you can see it, but every once in a while it just fades away. And we don't know what's happening. It's not like this one. This one we can explain. This one we really can't explain. So we refer to it as a reverse nova because it kind of has the same sort of thing, but rather than getting bright periodically, it just gets dim periodically. What they think is happening is they think this star is kind of burping out gases and clouds of dust and carbon, and when a big cloud of carbon gets burped in our direction, it blocks the light until it disperses away. It might be burping all the time, but if it's not burping at us, it doesn't dim the light. That's one theory. Hard to say for sure. But R Core Bohr is certainly an interesting star. Whenever you look at the Northern Crown, look for R Core Bohr right inside there, and if you can see it, you know things are normal. But if suddenly some night you look and it's not there, you know it's burping up some carbon towards our way. Luckily we're far enough away we probably can't smell that. So that's our exploration today of Corona Borealis. I hope you can get outside. It's in the sky, and it's a nice one to find. It's just off the handle of the Big Dipper, just above Arcturus, White Hawk down in the corner, which is one of the brightest stars in the sky. Look it up. It's worth an explore. Thanks. We'll see you next time. Keep looking up.